it's recording, so this is really nice. And here you can pause, resume. Today we are going to speak about in data structures and algorithms. Here our topic is Gaussian elimination algorithm, and as to the data structures, we will take a binary tree. First of all, let us just go to Gaussian elimination algorithm and try to see that. Here I have given you the link which you can press on, and there will be some kind of a theory page which we can wait, it's not that exactly. I want this one, the theory, yeah. And here we can open here, and this is basically from one American university. I like this section, and they are just reconstructing, but here the linear algebra, they did it quite well. So here you can see the algorithm for the code, how we can implement the matrix multiplication, and you know that very well, we did it with you. But here we have also good things to operate, for example, with Gaussian elimination. And what is important to understand, that when you do the Gaussian elimination, then you work with the matrix like that. There is a possibility to change the form of the matrix. You can see here you have the matrix which is large, and all the elements are here. Like you can see all the elements are here with stars. It means that there is any element is there, and any number. But what we do afterwards, we create it so that only in the first row there is an element, but under this element there are zeros. And you can do this by making equivalence transformation to matrices. I don't know, I want to ask you, do you know what are these equivalence transformations to matrices? Have you heard about them before? Because you were to my mathematical class and we had it, but do you remember this? Or maybe you have forgotten, or maybe you came new and you don't know about this. Please tell me. And then I will just make the decision about that. So have you heard about some kind of transformation for the matrix which are making the matrix equivalent? Maybe you remember also, Roman, from previous. Not really. Yeah? It was like, you know, remember we were doing some solving of Gauss systems by Gauss method, and it was like you could add one row to another row or subtract one row. You remember something like that, yeah? So here, and you can see that here you have a matrix, and you have here some numbers, but here below you make them zeros. So what you basically do, you do some manipulations with these rows. Like there are three possible manipulations. You can take the row and divide it by any number which is not equal 0. Remember that, yeah? So you can divide or multiply the whole row by one single number. And what you can do, you can change rows by places. You can change, for example, the first row and the second row by places, putting second row in the first row position and putting the first row in the second row position. This you also can do. And the next thing you can do is you can add one row to another row as many times as you can. So what you basically can do, I can just write it here so that you remember, or you see we have here our last lecture, so this we will delete, and I can do what actions can be done on matrices, not changing that do not change matrix value. Yeah, so you get the equivalent matrix. So you get the equivalent matrix if, first of all, rows of the matrix can be interchanged. It means the position of rows. Yes. Do you understand this? So you can just take one row and put it into another row, but the next row goes into the place. So you can change places of the rows. So one row can become the second row will become the first row. Roman, is it understandable? So you can, in the matrix, you can change the rows. So what is that? I give you an example. If you have a matrix, for instance, you have a matrix like that. Let's draw a matrix. So here you have a matrix like 4, 6, 7, 8, 9, and here you have 3, 3, 0, 3, 2, 3, and you have the matrix, for example, like that. Here 2, 3, 2, 2, 1, 0, 7. So this is the matrix, and you can say that this matrix is equivalent. You know that the word equivalent, it means that it is the same, but it's a little bit different form. It's equivalent to the matrix like that. So here I can do the following case. You see, this row I can put, for example, here. This row I can put here. And this row I can put here. I hope you understand. What I did here, I just changed the positions of rows. You see, this row was here, and this row is second row. But here, this row becomes first row, and this row becomes the second row. So I changed the positions of rows, but what happened, matrix doesn't change about that. Is it understandable, Roman? Yeah? And guys online, is it understandable? So this is what you can do. Another possible action is it is possible, it is allowed to divide or multiply any row by any number that is not equal 0. Yes, so it means that any number not equal 0. I hope you understand. So it means that in case you do like that, you can say that for instance, you have a matrix like this, and you decide to let me delete those matrices, and you decide to take this row and divide by 4. So what you do if you divide by 4? So here will be 1, here will be 6 over 4, so it will be 3 over 2. Yes, here will be 7 over 4, here will be 3 over 4, and here will be 1 over 2. I hope you understand. Yes, so you divide it by 4. And this one will stay the same. The only thing I need to make it a little bit like nicer look, so that each element goes under each. And this is that matrix. Yes, so you can say it like that. And the same you can do with this, guys. So here you see those matrices are also equivalent. So if you take one single row and divide it or multiply it, you can also do the following, like you can make equivalence of different kind of things as well. You can multiply, for instance, yeah. And what means multiply? You can take this row and multiply it, for example, by 5. Then what will be here? Here will be 20, here will be 30, here will be 35, here will be 15, and here will be 10. So and here I will leave these rows as they are. I will leave them as they are, And what do I finally get? I get the equivalent matrix. Once again, what is equivalent matrix? It is the matrix that actually which can be used instead of that matrix. So all these matrices have equal power, or they are equivalent. And you can use, instead of this matrix, you can use this or that. Understandable, Roman? Yeah? And the guys online, I hope you also understand. If you have questions, please ask. And it means that these actions can be performed. And another action which can be performed, I told you there are 3 actions which can be performed. And the third action which can be performed is the following. What you can do is, it is possible, it is allowed to add any row to another, to any chosen row to another row of the matrix. And this actually does not change the action. And if I just copy here, what I can say, I can make it possible to see. And you see this guy, for example, is standing here, so this row changes. And this row, for example, I want to change this row. And I want to change this row, and no, maybe I will leave it as well. I want to change the row, for example, like this. A row, the first row. I want to say a row 1. I will subtract minus row 3. It is possible to do. You can do in different ways. And then if you do like that, then what you have here? Here you have, if you subtract from this row the row 3, here you will have 4 minus 2, it will be 2. Here you will have 3. Here you will have 6. Here you will have 3. And here you will have minus 5. I hope you understand now how it works. So it is possible to just subtract one row from another. And it is also possible to make now, for example, one more modification. It is here you can subtract, or you can subtract, for example, from this row, you can subtract that row. This is also possible. And you can write like row 3 minus row 1 now. Yeah, so. And what you finally obtain is you can see that this part stays the same, because it doesn't actually change, as you don't affect it. This part also stays the same, but this part will be different, because from that one you are going to subtract the first row according to this, and then here you will get 0, here you will get 0, here you will get minus 5, then I will move those numbers here. Here you'll get minus 3 as you subtract, and here you are going to have 12. So, and you see those matrices, they are equivalent. Is it understandable? Okay, so this is important to know, that you can do only these 3 actions, and these 3 actions can change the way how the matrix looks like. And now if we return back to our theoretical page, you can see that Gaussian elimination algorithm, the main essence of it is to change the form of the matrix. So it works with matrices. This algorithm is necessary to work with matrices, and if you apply it, you create a kind of a matrix which is in the triangular form. So look carefully. You had such matrix, but here you have such matrix. And if you have fully triangular form, it means that the matrix is square. So the number of rows and the number of columns is the same. So here you can see that Gaussian elimination is one of the oldest and most widely used algorithms for solving linear systems of equations. So this algorithm was explicitly described by a Chinese person in 263 while presenting solution to the famous Chinese text Zhanzhu, the 9 chapters of the mathematical art. You can see that the year of algorithm is 263. So it is almost 2000 years ago. And this is the mathematical thing, yes? So this is like this algorithm, but it still is good for solution and especially using on the computers. And you see, it was even discovered earlier. And why it is called Gaussian elimination? Because Gauss was the mathematician, but he was using this algorithm to predict location of celestial objects, using the newly discovered methods of least squares. It was like mathematics. That's why it is started to be used by Gaussian. But you can see that this algorithm is basically old, very old. And you can apply row operations to transform that, and here you have the back substitution. And sometimes you can also see the improved Gaussian algorithms. You can create the matrix having only diagonal without even those numbers. And we can try to figure out maybe this as well. But at the moment, it is the following. So what you can do is that you have such algorithm now. And here is the code, the fantasy code of the straightforward implementation of Gauss elimination. So let us try to analyze that code. I will increase it a little bit so that you see it better. So what do we have here? Let us try to analyze that code, which is written in pseudo language. So here we have what? What is that? It's a cycle. So it's a cycle, and most probably n is the size of the matrix. So here it is the size of the matrix. Now there is an interesting thing. What is the pivot within B? And here we have interesting case. What is that B? And here I want to warn you that we are coming to solution of linear equations, as I told you before. And you can see this is the linear equation. What is the linear equation? It is the equation where you have different numbers of unknowns and the number of equations. So here we have 3 unknowns, 1, 2, 3, and we have 3 equations. This part from mathematics, maybe you remember, this part is the matrix itself, yeah, but this is the right part. So the part B, so this is the vector for these solutions. And we call it matrix A, and here matrix B. So that's why in this algorithm, here if you have A, this is the main thing about that matrix. These are elements of that matrix, but B is the right part. Understand? So I can show you this equation like that. So here we can go further to skip those things, but if you have imagine you have equation, for example, like that. You solved this in school. 5x plus 7y is equal 10, and x minus 2y equals 8. So this is the system of equations. Do you know that? Yes, so agree. And we can call it in the matrix form. In the matrix form, it is written as A times x is equal to B. So where A is the matrix of coefficients, B is the right part matrix, and x is the matrix of unknown variables. So here where we can say where A is equal, and here you can have the matrix 5, 7, 5, 7. here it will be 1 and -2. Oh, sorry, -2. Is this understandable? This is the matrix, yeah? Then what about matrix X? Matrix X is the matrix which contains only two arguments. It is X and Y. So this is the matrix which we have like matrix of unknowns, right? And the next part is B, and this is the matrix which we have the right part. We contain the right part, so here we'll be having 10, and here we will have 8. So this is the right part matrix, which is only one column. This is the matrix which we need to find, so this is the solution matrix, and this is the matrix of coefficients. And if we return back to our theory here, this is the matrix 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. It is the matrix of these coefficients, yeah? And we have to modify that, but the right part also has to be modified, but it should be like this. And here, if you have this something like a fantasy code for this, you have to have you see here bj. What you are doing, you are creating a kind of a new thing. So what is there? It is here you have the row, yeah, this is the row, and what you are doing here, look, you are creating bj is minus bi multiplied by this divided by that part. So here it is you are trying to make it you are trying to divide by the element in the row, and then you divide all the elements there, but only for this one, for one and the same. So here you have these are the diagonal elements, basically. These are diagonal elements. Sorry, here I need to accept students. Okay, and you can see a pivot within B and pivot within A. So here, this is what you're doing, the pivoting. And here then, there is one thing that if you have AII is 0, which is bad, then the code divides by 0 and fails. So this is important, that you need to eliminate the possibility to divide by 0. And that's why you have to see something like that. And here you have also to understand that if you have a 0 coefficient, then it needs to be like some kind of thing that it will be very small. And here you see there is a program, Gaussian Elimination. We can try to take this in Java, try to launch it, and try to understand it. So I will just click on this program, because we will see it step by step. We will try to analyze it and try to see what is there. So here is the downloads. Now here is the Gaussian Eliminator, and you can see that this is this program. This is this program in Java. I think that you can also click on it, because Artem, if you can get it from in the Moodle. So if in the Moodle there is a link, you can click on it, you can get the same. So you can quickly take the code of the program, and we will try to implement it in Java now, and we will try to solve it there. So let us try to copy the code. Yeah, and if we copy that code, we have to open the IntelliJ IDEA. Here we open a new project, and we will make it Gaussian Elimination. And here, let us now just create the project, a new window, and we have now to create a class. Remember, the class shall be named the same way as the class inside the code, and here it was Gaussian Elimination. I will check it, and I will delete these entries and enter the code. And here you see Gaussian Elimination. you have some kind of red here, then you have to copy the name. But I'm having red not because of this. I'm having red underlined because here I saw there was some kind of error. It's like std out. We usually don't have it in Java. We write system out println. So here we system out println, and now I think everything is okay. Let us have a look on the code. Just do the same with me. This code is not really large because on the internet you can find different variations, and some of them are larger, having hundreds of rows, but here we have only 67 lines. I think we will be able to understand what is that code about and how it works, and then it will be clear for you how this linear algebra works. Because if you have a look into the theory page here, if you go down, you can see here are many different other algorithms as well, and here there is also some kind of things that is used for picture analysis and the picture, how to say, transformations, and you can see that all these algorithms, they are used in our linear algebra, they are used in artificial intelligence, machine learning, image recognition, and etc. So that's why it is nice to have understanding at least about this algorithm, because it's quite simple, and we already took you see here also Strassen matrices, they also have something like that, and so on. So basically those are the algorithms that we learn everywhere, not only here but in the US as well, and because they try to help you understanding the linear algebra and solution of linear system of equations, and a lot of problems are reduced to linear systems of equations. Okay, so this is what we have, and let us try to launch it. So here we have, I will launch it, and because I need to check if it works. I still have not explained what is the result, but here you can see some kind of result. Let us try to interpret what is that. For this person, we will have to find the driver method in our Java code, because here you can see that you have a public class which is main. Here you have some public static double method. Method double is not needed. We can make it like that. You can see here you can open and close. This is very good also in IntelliJ IDEA, that you can have those little symbols. If you want to open this method, you can press on like this, but if your method is like that, you can just make it this way, and it will be it will be collapsed. So it will help you understand where it ends, because it is not the driver method, because the driver method, remember, it has to be having some kind of this static arguments, and here you have public static void main string args. This is the attribute of the driver method. And here you can see what we are going to have. You have integer, it's n equals 3. So we have the size of the matrix. Here you have A matrix, which is this way. Here you have B matrix, which is this way. And here we have to find the solution. And here you just basically print the solution. So the whole algorithm is actually in this method. So if you want to go to this method, then you need to press Control, make the cursor over the method, and you can press on this and navigate to the method itself. You can see it goes to the linear solve method. And yeah, where is this code? So we can continue, and I don't know if now it is probably, yeah, because I'm recording the screen all the time, checking if it's working. So we can continue, and we have to understand what is that thing. Now let us try to understand it together what is we can speak about each part of that sentence. So I think the driver part is not really interesting, because what you have here, you have the definition of the size, you have the array, which is 3 times 3 array, because you can see here are 3 rows and 3 columns. Okay, here you have defined the B array and X. So if you remember, I told you that we have this matrix, and for this equation is the following. But if we return to our equation, I can say that I can reconstruct it so that you better understand. If I copy that to my notepad, then I have this array. I have this array for A. Now, what does it mean? Let us try to understand. So this array is for A. Then this array is for B. So can we reconstruct the system of linear equation? Then we have the following system of linear equation. 0x plus 1y plus 1z equals 4. I hope you understand. Yes, so because this is the row, and that's why we have such coefficient. It means that I will write them now like this, and later we will make them looking simple. And here we have 2x plus 4y minus 2z equals 2. And the final equation is 0x plus 3y plus 15z equals 36. This is the equation what we have. And if we want to find it a little bit in the nicer form, then this can disappear. This can disappear, and this can also disappear. And moreover, this also can disappear, and this can disappear, because we don't put 1 there. Yeah? So this is important to understand. And this is the equation that you are about to solve, but you have to enter it in the following way. This was a little bit like to understand. So what you have here, as one more time, you have entered the array, you have entered the another array, and here you need to find x. But what is that x? You can see that this x is defined as array. So basically you are looking for x, but x is the matrix. X is the matrix in the form, it is in the form like that, x, y, z. But it's a vertical matrix, yes, vertical column. Because if you multiply it, then you get the same. And here is the method. So, and then initial, you have a and b there. Let us go to this method and see what is happening here. Of course, it is public static double solve. You see here we put this the type, what it returns, and it returns what? It returns array, because we have defined array. And array of what type? Of type double. Why double? Because we cannot have integer numbers all the time. We can have different numbers here. Okay, so here we just put the internal arguments. So in order to start implementing this method, we need to give matrix A and the right part B. It is logical. Yes? Now, what is written here? Now you are just experienced guys already. Yes? So how do you think, what is that? What does it make?
The length of the array.
Yes, it defines the length of the array because we are given the array A and we are given the array B, so we define the array B. So we need to have it. We need to know how many rows we can have. This is important to understand how many rows we can have, because sometimes it is difficult to get it. And so what we have here the cycle, as you told before. And let us see, you can see here, you can press and you can get what is the cycle about. And now you can do it like this, you can open it. So what do we do here in the cycle? It's quite big. You can see it's quite big. I can double click on it so it will be clearly seen. The whole cycle is here. I think it ends here. So basically now you can see the whole cycle. And let us try to analyze what happens here.
Can I focus?
Yes, sure. We are coming with iterations. What kind of iterations we have? How many iterations we have? Do you?
As long as the arrays.
Yes, so it was the number of rows which we have. Yes, so because B is having all the rows which we have, so we are getting to understand if we are taking each row basically. And you see find pivot row and swap. So this is the command which maybe helps you to understand what is happening there. But before we discuss this, I want to pay your attention to the rules. What actions can be done on matrices that do not change the matrix value, that keep matrix equivalent, yes, to the new matrix. You can change rows by places. You can interchange the rows. If you have row in the position 1 and row in the position 5, yes, you can change them, and the row which was first will be fifth, but fifth row will be first row. And this will not change the matrix meaning. So the matrix will be equivalent. And here I give example because if you have initially this matrix, you can change, for example, first and second rows by places, and you get equivalent matrix. This is the size of equivalence. Understandable, yeah? And this is what we can do. Now you see find pivot row and swap. It means that if we have a kind of pivot row, it means that the row which we are going to have. But here maybe they have something different. Let us try to see what is happening here in this section. So firstly we make max equals p. What does it mean? It means that we are taking p according to the cycle. Yeah? And why we need this? How do you think? Any ideas? What?
What is P again?
What is P? Look, here is P.
Oh, okay.
It is the iteration. And we are now, when we go through this cycle, what we iterate by?
So, rows.
We iterate by rows. And it means that initially you have 0, and here you have max equal P, so it will be 0 first. But then what happens? Then what you do next, you iterate again, yeah? So, and what you iterate by, you are iterating starting from the next row. You are taking the next row and you change all the names. And what you do there, what do you compare? You see, you're comparing absolute value. But what is written here, absolute value? Here you can see all the time we have P and P. But here we have I and here we have max.
Yeah.
What was max? Max was the current position of row. Yeah. And then what is having here? Here we have the next one. But this is actually, it is not actually the row, but what is this? It is pivot row. So no, here it is row. So this is the row. So you take the first element, and you start. You are comparing what? You are comparing actually. This one is 0. You are comparing them by columns. So it means if you have created a matrix, if you take kind of a matrix like that, what do you compare? You compare in the initial phase you compare this element and that, this element and that, and so on. Do you understand? Yeah. 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 So here you have you are comparing it, but what you do here, So it means that you go forward, and if math ABS is, so you are comparing by the ABS value. What is ABS? You know, it is like it doesn't depend on sign. So ABS, it is like the value without sign. And if this value is larger than the previous one, because the previous one is this one, then what we do, we make max equals I. So we create another, we just remember the maximum, the maximal number there, yeah? The maximal number in the row, in the column, actually. In the column. Because here we are going column by column. So, okay, we do this. What do we do afterwards? Now we have to introduce some kind of new what are these? What are those things? And you see where it is written. It means like here, this cycle finishes, so you just calculate what is the maximum value. This is important. We have to find in which row we have the maximum value. And what we do is that, you see, how can you comment this line? Guys online, you can also
create a temporary array.
Yeah, but why we need it? So what basically is done there? You see, you create a temporary array, then what you do, and why do we need this temporary array?
We use it to record the value of. So basically, we create an array, a temporary array that is the copy of.
Mm-hmm. And what is the meaning of that line?
Array A with a number of spaces B.
Yeah, so what is the meaning then? You see, and here is interesting because A basically is two-dimensional array. But here we are making only one dimension. What does it mean?
Maybe we copy a row.
Yes.
We
We copy the row. So we take the first row, yeah, and we copy it to the temporary. No, we take the row number P and copy it to the temporary variable. And then we substitute this row with a max, with the maximum value we have found, and then we just put into previous value the initial value. So actually, guys, do you see that this line actually implements the swap operation? Here you swap the rows, but here you determine which rows you need to swap. Do you get it?
Yeah.
Yeah? Okay, because later we will try to debug and you will see that how it works. But now we are trying to analyze the code because we can go through. Yeah, please welcome. We can go through and we can actually understand how it works. So that's why I wanted firstly to analyze the code. So for now, this is clear that we are taking the pivot row and swap it, and the pivot row is the largest one. Yeah. So where the first element is the largest one. Okay. So now, what is the next one? Look, let us try to see here, because this cycle is quite big. So here we just swap. Here we have singular or nearly singular. So, and remember here it was the constant, and if you just click on that constant, so here we have it like that. So what can you think? What do you think about those things? What is this epsilon constant? It is 1 e minus 10. Have you heard about something like those numbers? What do they mean? Do you know that? Have you heard about what is that kind of constants? Because sometimes in the programs you can receive those things. What is the meaning of that?
I've seen it in a calculator when the number is too big.
Mm-hmm. What?
I've seen it in a calculator when
Yes,
numbers.
yes, and you don't know that. Okay, I can explain. Other guys, maybe you know about this. What kind of number is this? You see here, I will copy that and I will explain you what is this one. So here, let me just clean the thing so that you don't see the previous ones. And we have something like that. Double epsilon is equal to 1e to the power minus 10. And you cannot know what is that, but I want to understand what is this. And firstly, let us speak about double. Do you know the word double? It is the special type of variable. Why do we need double in our calculations? This type of variable. Why do we need double? To write the numbers with comma. Remember, there is type integer and type string. It is for letters. So in double you keep number with commas.
What's the difference between a double and a float?
And float. Good question. There is a slight difference. So is double and float. Remember, the second lecture which I give you, it is the computer architecture. And we were speaking one day about IEEE 754. Do you remember that? There was this standard of number representation.
I know it exists, but I don't remember.
Yeah, and this is the standard where you have. Okay, if you don't remember this one, I can tell you like that. The range does matter. What is the difference between double and float? Float has 32 bits. Has 32 bits to remember to store the value. Yes, to 32 bits to store the value of a number, but double has 64 bits to store the value of a number in a memory. So what does it mean, having 64 bit or having 32 bit for storing the value? It means that in double your number can be more precise. You know that sometimes the numbers have infinite number of digits after comma. For example, the number pi, yes, it is approximately equal. Do you know this number pi, yes? And it is approximately equal 3.14, and I think here is 5.9, and so on and so on and so on. But you will never find the end of those numbers. Remember that. And it means if you take double, you will have better precision, because you will have 64 bits to store the value. But if you have float, then you have only 32 bits to store the value. It means that you have more digits to save in double format. Yes? I hope it's understandable. And now we need to figure out what is that. So here epsilon is the name of the constant. So it is like name of the variable. I think we don't need to speak about more. But what is this notation?
Sure, it's like 10 to the power of minus 10.
Yes, it is exactly like this. It is 1 times 10 to the power of minus 10. So epsilon is equal to this. So it means that if you have something like that, then this is actually the same as 1 times base to the power of minus 10. But E means base of the numbering system. But as we are using decimal binary system, the base of the decimal numbering system is 10. So here we have 10. And it means that this is the amount. So what does it mean if we just try to understand what is that? It is 0.00000000001. This is that number. Do you understand it now? Yeah, and in order not to write this in such long form, you can write it in such a form. Okay, this is how we store the value of a number. If you put here 12, it becomes, if you put here 12, then you just need to add 2 more zeros, yeah, and that is will be to the power of 12. So here it is the scientific notation. It is scientific notation for of that, yeah. So this one is scientific notation. This is scientific notation. This is scientific notation of a number. I hope it's clear. So let us return back to the software, and now we understand that. And now what we have here about singular or nearly singular. So here we have some kind of if, and this is also a good structure for understanding what is exception. And so if you say throw new exception, what does it mean? Matrix singular or nearly singular, it means that it is like an error, because if you have something like that, it's going to be error. And you see here what is happening when we have an error. So if you have ABS of this matrix, for example, you have ABS APP is smaller than epsilon, it means that you have very small numbers inserted in the matrix which are below this threshold. We have introduced this threshold. If number is below this threshold, we think that this number is almost zero. Yeah, but with zero we cannot operate, so that's why it is like this. Okay, understandable. This is for understanding whether the matrix is singular or not. We can try to get it. You see, here we have 0 and 2 and 3. What happens if you put here 0? Then all the elements in the row will be zeros. If I now start executing it, it's gonna throw me the exception. You can see that here exception in thread main, matrix is singular or nearly singular. You can see we have done this exception because you have had here that 0, 0, 0 is below the threshold. But we can write also the following stuff. Remember, here was 2, but I will put 2e to the power of minus 11. So you understand what I'm written here. It is like 0, 0, 0, 0, 11, 10 zeros and 2 at the end. So this is the numbers. I can write also in such a form: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 2. But this number is not really good to write. So that's why I'm writing it in this way. Yes, so please understand. And now let us try to launch it. Again, you will have again the exception, because this number, yeah, you see, again you have exception, because this number is considered below the threshold, and then it is also considered to be 0. But as soon as you make here, for example, 10, then it shall work, because I have 2, but there it is 1, so it is a little bit more. So if I start operating it again, then you can see that there is the solution. Understandable? Okay, very good. Now I will return back to 2, and there are nice solutions when you have such coefficients. You have -1 to 2, and now let us understand the next thing. So here you can see this is the matrix singular or nearly singular, and if I just open it again like that. So what is this is one next thing. What do we do here? So we have done it. We have put here basically the above there is now the the maximum value we have done, and we have changed the rows, and now we have to see what is written here. Now just have a look and what you can say about that stuff. How do you think? What you can say about that stuff? What is happening there? Maybe it's difficult to understand, yeah? So let us try to debug, and then we can see what is there. So do you remember how to debug? We need to make a breakpoint, so let us try to make a breakpoint exactly here, and now let us start debugging. Sorry, I pressed the wrong button. I need to start debug. And if we start debugging, hello, okay, so it's sorry, cancel. Well, so here we are, and here we are. So here we have the raw format or the JSON format of B, and here we have the raw formats of A. So at the moment, when we are inside this method, what we have this is the structure of our matrix, but B is the right side. Remember, I told you this, we were solving this equation, and this is how we have those equations. And we have 0, 1, 1, 2, 4, minus 2, 0, 3, 15. And here is exactly the same, 0, 1, 1, 2, 4, minus 2, 0, 3, 15. And the right part, it is 4, 2, 36. It is 4, 2, and 36. Yes, 4, 2, and 36. So this is initial data. Now we are going to here, so we're going forward, we step over. We go into the cycle, and you see n is equal 3 because we have 3 rows. Now what we are going to do, we go next, and firstly we introduce max part. So you see p is 0, why? Because it is the new iteration. So let us see what happens. This maximum value is done, so max now is 0. So the program thinks at this moment that the maximum value is the 0. Now what we have another cycle, what we need to change here? We need to go starting from 0 plus 1, so it will be starting from 1 to 2. So we will have 2 more iterations. And what we are going to check, we will check with 2 iterations these values. So here we go forward, and now we have this one and this one. Do you remember what was this? If we look in the matrix, what is at the moment A, I, and P? I is equal to what now? You can see I is equal 1. And what is P? P is 0. So what is AIP? A10. And this is what number? If we have this matrix, what is this number? Yes, it is 2. It is 2. So then we have to, and what do we compare it with? We compare it with max. But what was max? 0. So it's compared with 0, 0. But 0, 0 is 0. So we compare this and that, 2 and 0. 2 is larger than 0, is it true? So what we have, we receive that maximum value is changed. So maximum, we change the maximum, the index of the maximum value is now new one. So we say max now is the 1, yeah? So because we start from 1 here, remember? Now let us try to make it. So you see here, and you can see after this execution, you obtain that maximum value is 1. Now we go forward, and we increased it by 1, but we still have the cycle to continue. And now the I is equal 2, as you see. Yeah, it is the final one iteration, because you have 3 rows, and it finishes at 2. So this is the final iteration. Will this hold true or not, this part? Now, if you have I equals 2, and remember max is now 1, so here you have I equals 2. It is 2 and 0 because p is 0. What is the coordinate of 2 and 0? It is 0. Yeah. So, and we compare it to ABS. Max is equal to 1, so we compare it to 2. So 0 larger than 2, it doesn't work, so we will skip it. Look. Yes, you see we skipped it, and now we are here in in the final iteration. We have int equals and I equals 3, but I equals 2. I equals 2, and now it will be I equals 3, but we are going to skip this because we're already out of the cycle. And now look, this way what we do is that you make a swap, and you can see p is 0, temp max is 1. So you swap the 0th row and the first row. And here, look, now you have A this part and B this part. Now I will execute it. What will change? This and that will change. Look carefully here and here. Please have a look. You see it changed. So it changed because this was the swapping operation. Now tell me please, what will change when I execute this line? What will change? How do you think?
2 and 4.
Yes, in the B, yes. Here will be this one and this one will change. And look carefully, it will be exactly like this. You see, they change it. Okay. And now we have to speak about singularity. Singular matrix is the matrix where it has all the row or all the columns equal zeros. That's why it's singular matrix. And singular matrix are difficult to solve. Sometimes they are unsolvable. That's why it's important to check. And here we have again this one, but it doesn't. In the first one, p is 0, so a0 0 is. We are checking now. You see here p and p, and what happens all the time here? We are checking the diagonal element, because pp means that the index is equal in both for rows and columns. And where are such elements? It is the diagonal elements. For diagonal elements, all the time, row and column index coincide. I hope you understand it. And that's why you are checking the first element in the diagonal. What is diagonal? It is this element, and this element they are checking. And now it will not hold, it will be less than epsilon. Let us try to see if it's less than epsilon, because p is 0, I think it is less than epsilon, yes, so, or not. So let us try to figure out math ABS, and we can try to copy that, and you can insert it here, and you can try to figure out. You see it's false. So if it is false, then we don't go inside. It is false, yes. So because there is some kind of ABS, but p is now p is equal to 0, and if we have pp, we changed it already. So here it is 2 times 2. So we basically, why we did this swap? We needed to find the maximum value. So that's why we did it like this, and then we can try to get this. And here is we're getting the maximum value. That's why we were swapping the row. So I will go forward, and now we have here this method where we stopped because we need to understand how it works. Now let us analyze step by step. What happens here, guys? What is this line for? It is a cycle, yes? And cycle goes again from what? From p plus 1 to the number of rows. How many actions will it perform in our case? You can see int I is equal p plus 1. Who remembers what was p? Guys, do you remember what was p? No? Do you remember that? What was p? If you look above, where is p defined? It is initially we go row by row, row by row. So remember, initially we started p0, so we still are in p0. And we are taking the elements now, p element is this one, but we have made some swapping already, and now we need to do some interesting thing. Let us have a look what we do here. First of all, now we will go e equals to pi plus 1. So it takes it so that I starts from 2. Yeah, I starts from 2. Because p is 0, but no, but here is 1. So it will start from 1. It will be like the second row, not the first row. Because in the first row the index is 0, in the second row the index is 1, and the third row the index is 2. So now you start from the second row and go to the end of the row. Yeah, so here let us see, we go here, and now we introduce a new variable alpha, so some coefficient. How do we make this alpha? What is happening here? You have I and P. What does it mean here? I and P. So you divide something by something, right? But what do you divide by? So you get actually, here you can see that you are dividing I and IP. What does it mean? IP, but here you have P and P. This one stands for what? For column? It stands for column, yeah? And this stands for row. And so it means that if you have I, so it means that you are going through the through all the rows, and you try to divide the elements by p. So now we will divide by what? APP. Let us try to see what is APP. So because if we don't know what is APP, we can try to figure out it here. And this is 2. Yes, so at the moment APP is 2. And what is AIP? Let us try to figure out, because we have I is 1, so AIP will be equal also to 2. Yeah? Why? It is also to 2 because we start, no, actually is it also 2? Because we start from P0 and, no, it is 0, look. It is 0, result is 0, so this is 0. So alpha will be 0 because we will divide 0 against 2. Yes? So we can do like this, and we can see alpha is 0.0. Okay, we have done it. Alpha is 0.0. Now what we do, we try to find bi, and this will be, you see, bi minus alpha times that. Yes, so and here we have the new bi. What is bi? Bi now, I is what? I, it is 1. So what number is bi? If we have this matrix, can you tell me what is bi now? What is bi now? No. Any ideas?
It's 4.
4. Let us see. Let us see. You can take bi at the moment, and we can put it like this. It is 4, yeah. But now we are going to change it. How do we change it? Because you see here.
Alpha is 0.
Yeah, but because you see, but what is 4? It is like this. It is the second, yeah. Alpha is 0, so we will not. It will not change. It will be 0 minus. So we will basically not change it. It will be. It stays the same. If I make it, it's 4 because you subtracted something like 0, yeah. Then what again now we have? We have 4i. You see, we have done new, and now we do something with the coefficients. But why do we do it? We have to remember, because here these are allowed actions. This one, you know how to do it. We did it already. The allowed actions, you can change the swap rows, and we have the row swapping. But here we can say it is allowed to divide or multiply a row by any number which is not equal 0, and it is allowed to add any chosen row to another row of the matrix. And it means that here we also are doing, we add or subtract. We can say add or subtract. Then it will be more correct, because here exactly we subtract, because our aim is to make in the diagonals ones, and we are having here this one 0, and now we are going to go forward and make what happens here. So you see here we have int j equals p. So we start from 0. So these are the columns. Yes. So and we have to go through all these columns. So for all these elements we have to make. And now what we need to change? We need to change corresponding elements. So alpha is having, alpha is the coefficient which we have here, but it is 0. So this is the coefficient from, I think, from this one, yeah. And then we have to subtract this one, and we subtract it and make it like that. So here it is a minus j, and then we have it like 0. Let us try to see what we have here. So now we have aij. It is, what is I and j? I is 1 and j is 0. So it's row 1 and column 0. So this is this element. This element, and from this you will subtract that, it will stay 0 again. Like that. So it stays 0. Then here you have, again you stay 0, but and then you have this, nothing changes because alpha is 0 probably. And then now you will go out of the cycle. And now you can see that, do we change something? We have here p p equals 0. No, nothing is changed, and now we can go forward. You see, we went out, and now what we do, we are now having I, the next one, and I now is 2. So what we have come to the second row. to the third row. We have come also here. And let us see what we do again. So alpha again will be 0, I think, because, oh no, let us try to get here. It will be 2p. So it will be, how much will be alpha now, guys? Who can calculate? Because you have alpha is IP, so I is 2, I is 2, and P is what? P is 0. 2 and 0, where is 2 and 0? This is this part, this part. And it shall be divided to what?
Why is it 0?
No, 2, 0, because P is 0, P is 0, and I is equal to.
Yeah.
So that's why this element I, it is 2, 0.
Yeah, of course.
And 2, 0, it means it is 0.
Yeah.
This is 0, yeah. Okay, and divided by APP, what will be this one? 2, 0, and it will be A0, 0 by divided by 2, yeah?
Yeah.
So it will be also 0. And then we can go forward. Then here we have what we have here. Also BI stays the same, yeah, because the BI is 36. You see that 36. Why it is 36? Because you have I now equals P is equal to 0. It is 1, but it was first iteration, but now is the second iteration, it is 2. And that's why we are having this one, and here it is 36. No, it's logical because we have the last one. And 36, we don't change it. Yeah, so we don't change it. And now we have the next cycle. We need to change what happens with that row. And that row also changed by alpha, so we don't change anything as alpha is 0. So this way, and this way. And now we go out of that. And what we need to go, you see, we came to that again, to the next iteration. We came to I now is what? I is equal to, and I is equal to, so we will not be able to go forward, and then we shall go out of that cycle. Yeah, you see, we went out of that cycle, and we went above, so now we increase P. And P will be what now? This P is, it was, now you can see that P is 0, after that P is going to be 1. So we are moving again to what? We are moving again to what? You see, now what is interesting that our matrix, look how it looks like. You have 2 here, but here we have 0 and 0. So this is important that we have to have 0 here. Understand? And we have to have 0 here. This was the reason why we did like that. And now look what happens. Now we will go, P is 1, so we will go through these places. And what we need to do, we need to change only this small matrix. And now this is 1. So look what will happen. Now we are going to pivot and swap. We are going to find the largest of this. The largest of this is going to be 3. So we are going to put it there. Look how it works. So here we have it. Pi is equal 1. Now we have the cycle. And we start from 1, from 2 we start, yeah? Because pi is equal, P is equal 1. Here we start from 2. Yes, we start from 2 and until 2, until 3. So 2 is still working. 2 is smaller, then we can go forward. And we go here. So what do we compare? AI and P and A max and P. What do we compare there? Is I is equal to 2 and P is equal to 3. So we compare 2, 3. no, p is equal to 1. So p is equal to 1 and I is equal to 2. So we take this third row and we compare this element. And what kind of element we compare here? Maximum is 1. So this is 1. So we compare 1 and 3, those two guys. And it will be holding true or not? How do you think? Look carefully. Will it hold true or not? Oh, it's blocked. One moment. Oh, you can open it. Okay. Something happened that you cannot enter, yeah?
I'm pulling it in. I have to pull it
Ah, so you had to try. Yeah. Okay. So now, how do you think? Will it go through or not? It's not. We can check. You can just select it like that, and you can put the expression here.
Oh,
You can see it's true.
yeah.
It's true because, and then now we will have the swap thing. So basically, if this one is true, then we define maximum value. What will be there? Maximum now is 1, but after execution, maximum will be 2. Look. You see, maximum is now 2. We know that max is 2. Now p is what? P is 1, so we can go forward. I is 2, so we will finish this iteration. Yeah, we'll go here, and now we are going to swap. What we do, we swap, and you can see now we have 1, 1, 3, 5, 15. Now we will swap it, and here we have 3, 15, and here is 1, 1. Okay, we swapped. And now we need to swap those two guys as well, and we swapped here. So again, we double check whether it is smaller or equal than epsilon. It will be okay. It will go through. And then here we have the pivoting within A and B. So let us try to see. Now look what will happen. Our idea has to be that now you have to remove here the value and make it 0. Yeah? But how to do that? So you can see that now you have P how much? P is 1. But now it will be from 2. Yeah? So here, if you go forward, P is 2. No, P is still 1. Yeah. Why it's 1? We don't need to have P, we need to have I. And I is 2. Yes, you see, I is 2, because it's 1 plus 1. And yes, it is 2, so we go through. And now you see what happens double alpha. So let us try to figure out what will be alpha. How do you think what will be alpha? Give me a guess. Because this is the matrix. You know all these values. Give me a guess what will be the alpha. Remember, it is IP. What is IP? 2 and 1. 2 and 1, 1, 0, 1, 2, and 1. This is 1. And divided by what? By 1, 1, 1. It is 1, 1 by 3. So alpha will be 1 over 3. Let us check. Alpha is 1 over 3. It is like that. So now what do we do with 1 over 3? 1 over 3. Here you can see that now we go to the cycle and we need to change everything. What will be in the cycle? You can see J will be equal to P. P is equal to 1. So you will take the first row. No, the row is index 1 is the second row. And you will start J equals P. We will start from 1. And you will start until, so you will take this and this elements, but now if this is or that is, so because you need to go for I, but I is 2, so you will modify the last row, and you modify only this guy and this guy, and here you have to modify it. It will be 0 here and something here, because you are going to see this will be alpha divided by pij. But what is pj? It was ij, but here is pj. What is the pj? P is now 1. So you take the elements from this row and subtract from that, and with the aim that you receive here 0. So let's look like this. What happens? Now you have it alpha. You have the b. You can see here you have done b is basically -8. You have done it already, b -8, because it was how you calculated b -8. It was before, it was something different. It was 15. Yes, but then you have calculated it minus like that. So we have skipped it, but you have to understand that we have calculated that by using this same. But now let us calculate this this part, and here you can see now alpha. So you see here, what is alpha? Here aij, now I and j. What is this? I is 2, j is 1. So this is this element. And now you need to subtract alpha multiplied by the element which is above with p, because p is 1. So it will be 1, and j is also 1. So 1, 1. So this one is the element. So 1 minus 1 over 3 minus times 3. It will be 0. So you can see that here is 0. And now how much will be here? How much will be here, guys?
It will be 3 multiplied by 1 over 3.
No, it will be 1, this one, minus 15 times 1 over 3.
Okay.
So it will be 1 minus 5, it will be minus 4.
Wait, why is it 15?
Here,
Yeah.
it is because it was there given. It was given here. Yeah, here it was given. And you see now I am executing this. You see here it will be minus 4. Look. Yeah, you see it's minus 4. We have done it. And now it will stop. And we have to go through again. But we have to stop also because I is equal to 2. The next one will go out of the cycle. So we go out of that cycle. So what we have? We have here, you see the matrix is now in the triangular form. Do you see that? And the next thing is P will be equal to 2. Yes, so now P is equal to, this is the last iteration. So what happens in the last iteration? We need to analyze now this column. Where is the last element? So here, what we do, we have to have max pi is equal to, so p is equal to, so max is also equal to. Now it is false. Why it is false? Because if you have 2 plus, so it means that, bless you, we don't have to go there because it will be already 3, but it will be so it will not work. Okay, guys, we need to stop and make a break, I think, because we took your time. Then later we will continue. Now we have to continue our... Yes, you can go out. And here we stopped basically for this one. and at the moment we have such matrix. So it's a triangular matrix. Now let us see what will happen afterwards, because it has to go out of that cycle finally. It will not go inside here, as you see, because it's false already, because we are at this position and it wants to have next position, but there's nothing next, so we will go out of this. Here what we do, we see 2 and 2, they are equal, so when we do swapping, nothing will be swapped. So after swapping, nothing is swapped, and here also nothing is swapped. And this one of course will not go because we don't have this element. This one is also false because it doesn't go through, so we go out. And what we have, you see that now we have to finish that cycle. This was this first cycle which I told you. This was this first cycle, the first cycle. We are going to finish this, and then we have to make the back substitution in order to receive the answer. So now we need to go forward, and where is my debug here? So we go forward because we are not going inside this cycle anymore, and now you see we are going to back substitution. So what we do here, we have this matrix and we need to find out what is the solution now. As you see, now we have this matrix and this is the vector. So instead of this equation, what equation we have? Let me check. I will write here. This equation we had before, and now we have this equation. So instead of this equation, I'm having that. Here you have 2, 4, minus 2, so it will be here 2, here is 4, and here minus 2, and there is 2. So this is like that. Then the second equation is 0, 3, 5, 15. So here is 0, here is 3, and here I think is 15 with plus. So here is plus 15z is equal to 36. And then the last one is 0, 0. So here 0 plus 0, and here minus 4 is equal to minus 8. Yeah, minus 8. So this is what we have, and if we write it like that, we can exclude zeros, so we can write without zeros, because writing without zeros, it's even nicer. Like that it could be, and here it could be like this. So you see, now we have this equation, and it is easy to solve, because what we have from this equation, it is very simple to find z. It is just that part divided by this part. Yeah, yeah, that's why we find z. And then afterwards we can put z here and find that one. And all the time we're just making this. And so how it is implemented, you can see this is in the code here. Look, first of all, you can see this is the small one and this is the finish. So double x, you make a new array which is just a one-dimensional array, because we have to have the same as x, y, z, so it's like the same as the right part. And now you go through the dimensional array, but you start from the end. You see, so you are just taking the last but one, so you are taking, it is 3, but you will take from 2 to 0, because you need to go other way around, not from x to z, but from z to x, because firstly you calculate z, then you calculate y, and then you calculate x. So it means that now you are going other way around, and first of all you have sum equal to 0. This is special kind of things, and look what you have there. You have here you go, I think, for the elements for this. So firstly you calculate the second element of x, then you calculate you see here is the xy, and look what it does. You have the sum. What is sum? Sum is the element of aj multiplied by xj. But we don't have xj basically at the moment. You see, you have x, it is empty. So what we do now, we go to this way, we can go for this way, we can debug. So we have done this one initiation, but if we initiate, we already have zeros there in the array. It is logical. After that, you make a cycle. So you go now, you will have 3 iterations. Firstly, you will have iteration 2, then iteration 1, and then iteration 0. And after you have -1, you will go out of the cycle. So you will have 3 iterations. Now you are having the first iteration. You see I is equal 2. So this is the first iteration. And you introduce a kind of a variable sum just equals 0. Okay, let it be so. You introduce this variable. Then you get another cycle, and what you do for this, you are not going inside the cycle, because here what you have, if j is equal I plus 1, but your I is already 2, so you cannot go further. So it means that because you are looking for this way, but there is nothing after that. So that's why you don't go inside. If you are looking for y, then there is something after, and then you need to place it there and subtract. Yeah. And you see there is in this cycle you see how many times you need to do this sum or subtraction, because here you have this one plus 1, but here you have 1 and 2. So that's why if you go further, you just increase more and more. And this is interesting algorithm also, how it is implemented. So you see it's nice. And now it is false, so we don't go inside. And then sum is 0 at the moment, because we didn't go inside. But then we can calculate x2 by making, you see, bi minus sum. So bi minus 0. Yeah? And divided by, and you see here are brackets. It's very important that you have brackets, because all the expressions shall be divided. And here divided by the aii, this is the diagonal element. Yeah, and you divided by this one element. And very nice implementation, very good. And sometimes in the internet there are a little bit different implementations. So I like especially this one, because they have. So you divide it by -4, and what you get? Look, now you will receive this one, you will receive this one, and you see here, I think xi. You see here is -4. It has here. Yeah, you see ai. I don't know why it is. No, it is ai, but I need xi. Yeah, here is 2. You see, it is 2, because it was 2 when you divided -8 by -4. You will receive 2. Yeah. And now you have already n equals 3. N equals 3 all the time, but now I equals 2, but after this I will be equal to 1, you see? So now you move backwards. And again, if you have something in the sum, here again sum becomes 0. This is important. So now you put it forward, and now you have this cycle, because you need to make this sum, this one, because now you know z, and you can use it to calculate this one, and then you make it like sum. Yeah, understandable. And for here you will go twice, because you will know both this one and that one. So here you have integer. It will go only one time, because I is equal to 1, but it will be 1 plus 1, it will be 2, and then you will have only one iteration. So I will go forward. You see you have j is equal to, so this is the final iteration. You will not go further. And here sum now is equal 0 plus, and what happens here? aij. So you just calculate I is the row. Now you have the second row, but you start summing up all the things by multiplying the same element. You see xj times j. So the column j is the following. So this will be xj is z, but 15 is aij. Yes? And you are multiplying that. So what you have afterwards, you can see now sum is 0, but now it is 30. So it is 15 times 2. Exactly. And now you will not have iteration anymore, because it is the only one. You are looking now for this guy, but here is only one guy. If you were looking for this guy, you would have 2 times to sum. Yeah, but now you are only looking for this guy. And it means that here you have this one. And now you go out of the cycle. And you see now you have to calculate this. And what happens? You have b part, this one, minus the sum, and divided by this. Yes, very good. And here you have this one divided by this. So you are calculating it. You see xi is 0, 0, 0. Now you calculate, and xi is 2 also, you see, because 30 over 50, no, it was, how much it was there? It was 36 minus 30. It was 6 divided by 3, it is 2. Yeah, because here it is 30, here 36 minus 30 divided by 3, it's 2. And the final one, you go here, again you have double sum, and here you will have 2 times, because you see I is 0 now, and then it is possible to go 2 times. Then you see now sum is this way, but now if I go this way, I can introduce what will be the sum. I is 0, j is 1. It means that I is 0, it is the first line, but j is 1, it is this amount. So you will calculate this amount, and you already know this I because you have calculated, so it will be this element multiplied by xj, you see, aij. So aij, it is ij, it is this element 4 multiplied by this element, it is 2. So it is going to be 8, look, you see, it is 8. And now we are again in this cycle, and we have now j equals 2, so we again go to the sum. And you see here it is sum plus equal. So to 8 we will add this expression, minus 2 times z. And z is how much? 2. And here is minus 2, so we will calculate, it will be like something like 4, I think. We can calculate now how much is that. We can just calculate this separately because it's not there. I can calculate this, and you see it's minus 4. You see? It's minus 4. So initially we have 8, but we will subtract 4, and we will have 4 now. Look. You see, sum now is 4. And this 4 is basically over because we calculated this both. It will give us 4. And then from 2 we subtract 4 and divide by 2. So now we have this way we have to subtract, yeah, and it's gonna be minus 1, yeah? And that is over. Understand? Okay, so this is the return, and then we have lsolve is done. And now we just go to console, and we type the first, the second, and the third. And this is the final answer. Yeah? So this is how it goes. Understandable?
You are not recording the class.
I am recording. I will now stop recording.